Morning. Good news for everybody here. You don't actually have to just live with all of the garbage Unity creates for you. So, a little bit of a story to kind of set the scene. Earlier this year, my team and we went out to Korea to meet with a bunch of clients and potential clients, looking for sort of like the next hot Unity game to shine our spotlight on. And every team we talked to had the same complaint. They were seeing a lot of performance issues coming from their UI. These were mostly Korean action MMOs that we were dealing with, so think little display names for an MMO, like character names or hit points, coming up and leaving really rapidly. And they were seeing just really surprisingly large performance issues from this. And so I would kind of go over the best practices, split up your canvases, maybe switch over to Text Mesh Pro, what assigned distance field is, how to set up a memory pool. And I would give the same advice to every one of our clients. For every game, at every company, through a translator. So this is taking an immense amount of time going back and forth. And this is, thousands of dollars we spent sending a whole team of us out to Seoul. Thousands of dollars kind of sitting around the table, having these long, drawn-out discussions. So when we made it back to our office in San Francisco, I decided to take a look at what the root cause of this problem was. And I did this for a couple of reasons. One, to make sure the advice I had been giving them was correct. But also I wanted to sort of take a step back. I wanted to build a test case and really dig down through the process of tracking down memory allocations, where garbage comes from, how you find these issues for yourself, so that I could walk our clients through it. It would be you all here in this room today. This talk is going to be a little bit of a postmortem, a little bit of a best practices for UI, and then a whole lot about how you should use our tools to find performance issues in your own game. So if all you're here to do is learn how to render some UI really efficiently, you'll be able to do that, but that's not all that we're going to cover right now. So the test case I made, dead simple. I took our old friend, the sample shooter, which I'm sure you all recognize by this point, and threw some MMO-style name tags on the weird rabbits and bears and elephants. I needed to make sure that this would support international fonts, that it wasn't some unique problem with trying to render Korean in our old text UI system. So I made, the names for each character switch every frame between English and Korean. That gave us international fonts, rapidly changing UI, all in 3D space. Pretty good representation of what our clients had been seeing. And it was really bad. This is just the simplest UI possible. It's the image backed by, an image backing some text on a 3D canvas, shoved in a prefab, the same prefabs we spawn in the sample shooter. And that was causing almost 13K of allocations just from UI. Every time one of these things would spawn, just that little text and rect. Worse, it was also spawning 1K per frame, every frame just updating itself. So this is a lot of garbage collection. Every time that you're allocating in a frame that's coming from your heap of memory, that's filling up this pool that the garbage collector is looking at. And when that pool gets full, garbage collection triggers. I don't know if you know this, but Unity kind of has a, let's go with famously flawed garbage collector. I'm sure you've all dealt with it at some point or another. So, quick spoiler alert. I'm going to jump to the end of the talk real fast. If all you care about is getting your UI to be faster, the cause of that 1K of allocations is layout groups. In this case, it was a vertical layout group and a content size fitter. Every time those change, they have to figure out how to lay out everything again. They allocate a bunch of buffers to do it. So that's the actual source of the problem. Where that 13K, approximately 13K of memory allocations on spawn was coming from, that's the initial setup. Use a memory pool, that'll go away. And then if you split memory pools into different pools based on the kind of object that you're spawning, you'll gain a lot of benefits, a lot of performance, and a lot of control over exactly what loads into your game. I'll go into details on all this in just a second. So, who am I? My name is Will Armstrong. I'm on the Spotlight team out of San Francisco. The Spotlight team is a group inside of Unity that tries to change the sort of perception out there on, looks like a Unity game. Our goal is to really push the bounds on what Unity can do. And we do that by finding projects that are really ambitious, that are really trying to push the tech beyond where most users do, work with them, help them achieve that goal, and then take the lessons we learn from that back into Unity proper so that we can make it better for everybody. We act sort of like enterprise support, but you don't pay us, we find you. So it's a free service, pretty great. And our whole team is all ex-AAA devs. I was previously the lead on Firewatch, so we have a lot of Unity experience. We have a lot of general game experience. And we help different teams all over the world. So getting back to my test case. So I get back from this trip. I know this memory allocation is happening all over the place. I don't know why, but I have a lot of smart guesses. So I do the worst thing I could possibly do. I make my sample case, see that it's bad, and just start fixing things. I think I know what I'm doing. Like, I'm a Unity expert. It says so on my business card. Like, I can probably figure this out. So I go in, I change from the old text system to TextMesh Pro. I don't know how many of you have already switched over to TextMesh Pro. It's now our default font rendering. It's great. It looks better, uses less memory. I know it's more performant. I've read all the marketing materials. I figure that'll probably help. I go through and I know that canvases are a problem with UI. I kind of vaguely remember that. Every time that anything on a given UI canvas or sub-canvas changes, it has to re-batch the whole canvas. So you want to keep your UI elements grouped together in canvases based on their update frequency. Since I knew that all of these things were changing every frame, I knew I wanted them all to be on the same canvas. So really what I kind of wanted to do was be able to group up all of my name tags in one big list. Well, that's basically a memory pool. I don't know if everybody here is familiar with the concept of pooling, but basically rather than spawn an object and then destroy the object when you're done with it, at the beginning of your game you spawn all the versions of a prefab you're going to need, and then you have them all disabled. As you need one, rather than spawning it, you grab it off the list, turn it on, use it till you're done, turn it back off, put it back in the list. Lets you set all of your allocations up front, prevents per frame allocations, prevents garbage collection. The other thing it lets you do is stuff like this, where I'm like, oh, I need to completely reorganize how all of my UI is spawned. When I first did the sample test, it was all just a canvas inside of the prefab spawned with a little rabbit or bear or whatever. By moving it to a pool and pre-allocating them all up front, it was trivial for me to attach them all to the same canvas rather than have each name tag have its own. Anytime that you're performing an operation on every instance of a type of thing, it's a lot easier if all those types of things are in just one list. Since this improves memory behavior as well, I really highly recommend thinking about setting up memory pools for really anything you're going to be dynamically spawning at runtime. So spawning waves of enemies, turning on and off UI, animators, particles, bullets, projectiles. There's lots of really good use cases. We also have a lot of asset store solutions for memory pooling in a very generic way. I think most of them are really a great starting point rather than a good finishing point. Find one you like, learn how it works, and adapt it for your own game. Memory pools are one of those kinds of features that if you wait until your game is finished and try and refit it, it's going to be a ton of work. But if you start your game setting these memory pools up and just spawn using them the whole time, they're going to give you a lot of benefits, and you're just going to, at the end of your game, you're going to be very happy you did it early. So if you're dynamically spawning kind of anything at scale, if your game has any size to it, think about how you're going to pool your objects up front. So I did all of this. Great, cool. These sound like smart things to do. And yeah, it didn't help. Still getting 1K allocation per frame, still getting I had moved most of the UI allocation off of the spawn, which is what you're seeing here. So what I should have done first, correct step one, anytime you're trying to track down a performance problem, is to fire up the profiler. This is our built-in profiler. It's in like Windows profile. It's an incredibly useful tool, and I think not enough of our users necessarily go here first. You can see here that for this profiler, I've got it up on the CPU usage, but then I have sorted the entries by GCalloc. That's the easiest way to find memory issues. So if you're new to profiling, basically what you want to do here is fire up the profiler, and if your game is running slow like every frame, you're not quite hitting 30 or 60 or whatever your target frame rate is, sort by self. That's going to tell you how many milliseconds are spent in each function. Lets you dig down, find whatever the most expensive function is right now, make it faster, continue until your game hits frame rate. It generally doesn't take too many iterations of that if you're close. If, however, your game is running at frame rate most of the time and then hitting big spikes, you're running along just fine and then freeze, that's probably the garbage collector running, and that means you need to be worried about per frame allocations. So rather than sort by self, sort by GCalloc, take the top entry, figure out why it's bad, fix it, continue, do that a few times, your game will run a lot better. Also, this profiler doesn't tell me a lot. It's really spiky. Whatever that yellow is seems to be taking up most of the frame most of the time. It's really hard for a human to kind of even parse that out. So a quick tip, anytime you're profiling, especially an editor, you can decide you can filter out what shows. If you turn off VSync, you'll get rid of all those spikes. VSync is your computer waiting for your monitor refresh, and it's not really telling you anything useful in this case. So anytime you're profiling your game, just turn that off, unless for some reason you think VSync might be your problem. All right, so I'm mostly focused right now on these per frame allocations, not total memory. I'm pretty sure my memory pool has reduced the total memory cost. The sample shooter is a tiny game, but just for completeness, we do have a memory profiler built into Unity. It's a great way of knowing sort of the ballpark of where things are. It's a good way of looking for something that has gone horribly wrong. So in this case, I was like, all right, well, I switched over to TextMesh Pro. That probably saved me some memory somewhere. I fire this up. I search through this big list of objects. It tells me how much memory each of them is using, approximately, and it is definitely an approximate number. And I look through there until I find a TextMesh Pro texture, and it's enormous. It's a 4K by 4K signed distance field because I wanted the Korean to be very sharp. The glyphs are pretty high detail, so I had erred on the side of size. If I was using a traditional font system, I would need lots of smaller glyph libraries. Our old font renderer works by having different glyphs for different point sizes of font. TextMesh Pro has one for any size of font you want to render. So while this does look like one big giant texture, I know that that's the only texture I'll ever need for all of my font rendering. It probably comes out okay. How you get to this memory profiler is if on this, you see I've got one frame selected. If I switch down to the memory overall tab there, rather than CPU usage, there's then this button up at the top. You can see it there, kind of grayed out. It says Gather Object References. Your whole editor is going to freeze for a second as we go through and try and track down every dependency and figure out the size of everything that's loaded in your scene right then. And it'll then give you this report that breaks down where all of this memory is going. Really, really useful for if you're actually running out of memory on a target hardware. So you're running out of memory on phone or console. But this is, not exactly what I'm focused on here. I'm still really worried about these per frame allocations in the garbage collection. I'm worried about memory in terms of performance, not memory in terms of total memory size. The sample shooter's not big enough to really make that a problem. So back to my per frame allocation problem. You can see that this is coming from canvas, send will render canvases, which that's not a function I wrote. I didn't add that to the sample project. So I don't really know how I can track this down. So the next step is to find the source for whatever the profiler is telling you to look into. I don't know if you were aware of this, but we actually have open sourced a ton of Unity at this point. Our entire UGUI system has been on Bitbucket for forever. The package manager, I don't know how many of you have moved over to Pac-Man in 2018, but every package you download from there gets installed on your machine with all of its source, searchable, findable, editable. You can even remove it from your package manifest file, copy the folder from where it lives in your hard drive, and make changes to our packages. You can fix our bugs for your specific use case. So there's a ton of uses for these, chunks of the engine that we've exposed to you. The package manager also throws its code in a really, really weird place. So, I don't blame anybody for not finding this. It took me a while. I've got the path up there, but you can see it's in app data local unity cache packages, packageunity.com, then the package name. So it's a little buried, but it is worth knowing that and tracking that package code down. If nothing else, it is a ton of really, really useful sample code. Anytime that you're trying to do something that's similar to something that Unity has done in a package, you can go look how we did it now, which will really accelerate your own development. And then finally, recently we actually threw all of the C# code for the entire Unity editor and engine up on GitHub. So we have this Unity Technologies organization. Previously, there had been a community-created, decompiled version of this information that stripped out all the comments and was not organized particularly well, and there were some licensing issues. So when we unfortunately had to take that down, we replaced it with just actually the code, all the comments in place. You can see how all of this stuff works. It's not the entire engine. It's not any of our C++. It's not any of our NDA code from our partners, but it is a sizable portion of Unity itself. And again, just an invaluable reference. So speaking of us throwing a ton of code up, quick shameless plug. Just last week, I actually threw up a new tiny little utility solution on our Unity Technologies GitHub page for attaching a game object with a static GUID. This will let you reference a game object across scenes. It'll let you reference an object after you've saved and load all of your game state. Pretty useful. Just threw it up there looking for user feedback. So if you find yourself needing save load or cross scene reference, I would love for you to take a look at that. So, all right, shameless plug over. All right, now I've got the source code. I can start trying to figure out exactly what's going on. I know it's coming. I dig into the canvas and will render. I find this layout group on rect transform dimensions changed. That seems to be where my problem's coming from. I fire it up in the UGUI solution I download from Bitbucket. It doesn't have a lot in it. It's got a base implementation that's empty, so that's not doing anything. It fires off a coroutine. Coroutines do allocate a small amount of memory every time that they get created, but it only creates the coroutine on occasion. Doesn't look like it, it seems like it's allocating a small amount of memory, but not the K per frame that I'm seeing. So the only other line of code in that function is setDirty. So I dig into that, track down through a couple of layers of glue code. I get to this mark layout for rebuild. So if you're going to use the profiler, it's going to point you at all sorts of code. It's going to point you at your code. It's going to point you at our code. If you're digging through our code, it's going to be unfamiliar. So you have to sort of start working on your instincts for where memory might get allocated, where performance might be going. If you're looking to try and track down a frame rate problem, you're looking for big loops. You're looking for, nested loops, something that goes on every pixel, every vertex. If you're looking for memory problems, you're more looking for new, add. You're looking for instantiate. You're looking for anything that seems like it's going to allocate a bunch of memory. So looking at this code that have never seen before in my life, it's got a bunch of glue code. A getter probably doesn't do anything. Try register. Release seems fine. Initialize. Initialize sounds like the kind of function that allocates memory. In this case, I looked in there, and all it's doing is copying a rect transform nothing really that expensive. It's maybe doing a little boxing. So, it's not memory free, but it's not doing much. So it must be that weird try register canvas element for layout reboot, which I have no idea what that could be doing. So we dig into that function. And this is also not obviously wrong. It's doing a search over a list. That's not great. It's doing add unique. Okay, that probably is where our memory is coming from. Every time you add something to a list, if the list is not pre-sized, it might have to double. That's going to so that it can fit more elements in it. If that happens a lot per frame, okay, yeah, that's probably where the garbage is coming from. But I also don't have a great way of fixing that. Like, I could come in here and maybe pre-size this list, but I don't want to change UGUI code. I don't want to have to figure out how to recompile UGUI. Like, now I know where the problem is. It's not an obvious bug. It's not something that's clearly going wrong. I got to work around it. So looking through the source code, even if you can't change it, even if it's like the stuff that's on GitHub where it's decompiled Unity, you can't make edits to it anyway, you can't build it yourself. Just knowing that this code is not doing anything completely perverse, that there's no huge bug here, lets me know that it's now my problem. I have to work around it. I sort of know the limitations of the system better. So popping all the way back out, I know that this function was originally called from that set dirty in onRect transform changed. So what could be causing that? I mean, obviously, that function's well named. I got lucky here. I know it's dirtying a rect transform. It's got to be happening every frame because that's the problem I'm seeing is every frame we're allocating this kind of inordinate amount of memory. The other big clue is that it's part of the layout group system. And, spoiler, you already know what this ends up being. I'm like, all right, okay, I've got this text that's resizing. Oh, right, I've got text resizing every frame. Arbitrary choice. I had the backing image for those little nameplates match the size of the font in front. And since I'm switching between Korean and English every frame, that text changes size. Korean is a very compact visual language. English is fairly verbose, not as verbose as German, but still ends up being with some pretty long strings. So all I did was just go turn off the content size fitter and just said, screw it. Let's say I know how long name tags can be. I have set a max size. I go in there, turn off content size fitter, set text mesh pro to try and best fit the font size to the backing image. So if it gets a little bigger, it'll shrink it back down. Text Mesh Pro actually gives you a ton of different ways to handle the case where the sort of rect transform that you're using for your UI is not perfectly sized to the content inside of it. Many more, like you can overrun the rect, you can alter the font size itself. Since the font rendering is so much more efficient, that tends to be a pretty good win. And yeah, that was it. With just turning off the content size fitter, I get a K per frame back. Now I'm allocating nothing on a given frame other than this weird 90 bytes coming from some other chunk of UI that came in the standard shooter package. I'm not too worried about 90 bytes a frame. I didn't touch any of this content, so I was like, all right, that's good enough. Also, just FYI, if you're ever profiling in the editor, 90 bytes is kind of a magic number. We have a few different things that in editor only, in debug only, allocate memory for like logging purposes, and they generally return a 90 byte allocation for that's just the size of the string that we use internally. So if you ever see something taking exactly 90 bytes, that's probably not your problem. Try building an actual release build and profiling that. Okay, so I did all this in 5.6 because that's what our clients were using, but I figured, on the Spotlight team, I see a lot more than just the old 5 family of Unity. Who here is still mostly working in Unity 5? Anybody? Yeah, we got a few. It's a good workhorse at this point, but I wanted to make sure that this problem was real, so I figured I should check it in some of the other versions that are, I may have laying around. This is not even every version of Unity I have installed right now. It's a little ridiculous, actually. So, Unity 2017, Yep, still allocating a ton of memory per frame. Unity 2018, yep, still allocating a ton of memory per frame. This is just a real problem. This is not some transient bug. This is all working as intended. That's also a really good way to track down where problems are something you might be able to fix. Like, if you fire up some of our code from Pac-Man or GitHub or wherever and see that a problem goes away in a later version of Unity, there's a really good chance that there's a clean fix for it in the older versions of the C# code you might have. If a bug has lived through several iterations of Unity, it's probably something fundamental to the architecture. You're not going to be able to go in and just target and fix it. Moving to the more recent versions of Unity, that also meant I had access to the UI profiler. I've been trying to fix the UI problem this whole time, but since I was in 5.6 and we added the UI profiler in 2017, I couldn't use it. It's just one of the other options, like CPU usage or memory usage. It's very similar to our frame debugger, if you're aware of that. Really, really useful tool to figure out where UI performance particularly is going. In this case, it's got like a big green bar for the cost of laying out elements and like a blue line for the cost of setting up the meshes into different rendering batches. As you can see here, this was all layout cost. I could have figured out that it was my layout element much faster if I had been using the more modern UI profiler. But clients were in 5.6, so was I. You can see here I'm also, like this, my little simple UI is actually doing a ton of draw calls. Reason for that is that we draw everything kind of in order in the hierarchy, and just arbitrarily, I was, in my memory pool of all of these name tags, it's backing image text, backing image text, backing image text in the hierarchy. We draw from front to back so that you get nice occlusion. You can control the order that UI draws in. That means I'm changing material between every draw call. That means nothing gets batched. If I'd wanted to, I could have very easily gone into this memory pool and made it allocate all the backing images first, then all the text, but then I would no longer have those backing images occlude each other. So it would be a big performance win in terms of draw calls, but as you can see, the blue line isn't my problem, and it would mean that I lost some of visual fidelity of the final product. So this is, again, a really good reason to always be optimizing based on what the profiler tells you is the problem. Don't fix the blue line here, fix the green one. So if you've done all this, you've used our tools, they're really good generic profiling tools. They work on every platform, they're built into the editor, they're easy to find, they're easy to use, they're built for new users. But they're also not really accurate. Like the number of milliseconds that a function says it's taking is not the number of milliseconds that it's taking on hardware. The amount of memory that is allocated for a given texture in our memory profiler is not the amount of memory that is actually being taken on device. If you need to know that level of specificity, if you need to really get down deep into the nitty-gritty, every one of our platform partners has specific profiling tools for their specific system. And these are going to be a lot more accurate. They're also a lot harder to use, a lot harder to set up. So early in development, maybe you don't know exactly what hardware you're targeting, you don't have really strong limits on your systems yet, I recommend using our built-in stuff. They're perfect for the sort of low-hanging fruit. If you're allocating a K per frame, it's easy to do better than that. If you're trying to get the last couple of milliseconds back to hit stable 30 on PS4, yeah, that's when you want to fire up something like Razor and really dig into where those last milliseconds and nanoseconds are coming from. So, we started out with 12K of UI allocations on every spawn, 1K of garbage just being generated every frame, huge garbage collect hits really, really regularly, and I I rearrange the spawning a little bit, set up a memory pool, and literally uncheck the content size fitter, and we're now at 0. No allocations on spawn, no allocations per frame. No garbage being generated creating new AI, no garbage being generated just running the game. Still not perfect. Ideally, I would have put like all of the monster spawning in memory pools as well. The sample shooter just instantiates prefabs like it didn't care. Not really what I would recommend doing in your own projects. The sort of continuing this theme of profiler-driven optimization, do be very aware, like if you switch over some major system, something complicated like AI spawning, over to using memory pools, you change the way it's working, you can actually run into issues. Some of our components respond way better to like having a game object completely activated or deactivated. Some of our components work better if you enable, disable them. So if you're trying to save performance, you move all of your AI spawning over to a memory pool, and all of a sudden your performance tanks. Fire up the profiler, see where that's coming from. Like, for example, animators, when you deactivate the game object, they free up all their like temporary memory. They clear out their state. When you disable the animator component, none of that happens. So if you're very rapidly moving AI to and from a memory pool, you probably want to disable all of their components rather than deactivate the whole game object. If you're not, maybe vice versa, to keep their memory away. Point is, don't assume you know what's going to be fastest. If you make a major change, throw it in the profiler, make sure it still looks good. So, profiler-driven optimization, use our source code. It's out there. We've given a ton of it away. It's a really valuable resource. If you're not already in the habit of it, get in the habit of it. Have those projects just, in your most recently opened, in your dev environment of choice. Don't change layout size every frame, and use memory pools wherever possible. Looks like I am slightly over time, actually, but if you have any questions, there's my email address. I'll be around after the talk. Feel free to come up to me. I'm always happy to answer questions from clients. It's entirely my job.